Well, our goal tonight is to find a particular solution to a differential equation. So just to refresh your mind of what a differential equation is, and let's just get that in our notebook there. A differential equation is just like it sounds. It's an equation with a differential, or a derivative in it. Now, two quick examples would be something like dy dx equals 3x. Okay, we've seen that when we've taken second derivatives. That's actually a differential equation, something with an equal sign with a derivative in it. Or y prime equals x squared plus 1. Again, an equation, equal sign, with a derivative in it. So again, our goal tonight is to find a particular solution for these functions. Now I just want to slow down and really talk about what we mentioned yesterday. Finding an integral is the same thing as finding an antiderivative. Okay, they mean the same thing. You're going to see those words interchangeably, antiderivative and integrating. We talked yesterday about finding general solutions, and I just want to really get this in our notebook and really go over the vocabulary. So if I have the integral of 3x squared minus 1, I want to be very clear, what you're integrating is called the integrand. Okay, this dx here just tells you the variable of integration. If those were y's in here, I better see a dy. If this was a theta, this better be a theta. Okay, now let's go ahead and integrate that. Remember, we add 1 and divide. So this becomes x to the third divided by 3 minus x, and then I get that plus c. Okay, now these 3's can cancel, so I really just get x cubed minus x plus c. So I want to be clear, this plus c, okay, is what makes this the general solution. There are an infinite amount of answers that have this antiderivative. For example, if I said x cubed minus x plus 10, or x cubed minus x minus 50, or x cubed minus x minus pi. If I take each one of their derivatives, this would be 3x squared minus 1, that would disappear. 3x squared minus 1, that would disappear. 3x squared minus 1, that would disappear. So these are general solutions when I have this plus c because there's an infinite amount of answers. Our goal today is not to find general solutions, but to find particular solutions. Okay, so again, let's carefully label this. Number 1, find the general solution to f prime equals 1 over x squared for all x values greater than 0, and the particular solution that satisfies this initial condition. Alright, so let's start with step 1. Find the general solution. I want you to remember that math is a balancing act when we have equations. So if I want to integrate one side, I'm going to have to integrate the other side. Since I have f prime, and the question wants to know about f, I'm integrating, I'm going backwards. So I'm going to say the integral of f prime is equal to the integral of 1 over x squared. Now, I'm missing two things here. Each one is missing the dx to denote what variable I'm integrating with respect to. Now, without that dx, you're not going to get any credit on your exam. All right, so let's make sure we're not sloppy and we put those in there. Now, look how simple this is, of course. I can say the integral of f prime, who do you take the derivative of to get f prime of x? Well, that's just f of x, okay, equals. Now, if you're smart, and we did a lot of this yesterday, we're rewriting this. I'm really saying this is x to the negative 2. I need to add 1 and divide by that. So I'm going to get x to the negative 1 divided by negative 1, so divided by negative, plus c. And I'm going to rewrite that. I'm going to say f of x is actually negative 1 over x plus c. Okay? So what was my first part, right? The general solution to this function. Now it says find the particular solution that satisfies the initial condition. So you'll hear that term pretty much throughout the rest of the year, initial condition. That's just going to be the initial function they give you. All right, and so all I'm going to do is I'm going to say if f of 1 equals 0, I'm going to say 0 equals negative 1 over 1 plus c. Obviously, that's my x, that's my y. We've talked about that since 9th grade. And I'm going to get, let's see, 0 equals negative 1 plus c, so c equals 1. Therefore, my particular solution, and let's label it PS, the particular solution of f of x equals negative 1 over x plus 1. I'm no longer going to say plus c when I have a particular solution. I'm going to figure out exactly what that particular value is. And that's it. That's our simple step of getting a particular solution. We'll get our general solution, and then we'll plug in the initial condition. I'll do one more with you here, and then I'll give you some to practice. Find the particular solution to dy dx equals 3x squared minus 1 at the point 2, 4. So again, this is called, let's get it in our heads, let's get it down, the initial condition. Okay, the value we're going to plug in, the initial condition. And if I have dy dx and I want y, I have to clearly integrate both sides. So let's slow down and write it out. The integrate dy dx, I'm going to integrate 3x squared minus 1 dx. Okay, remember, it's a balancing act. Whatever you do to one side, do to the other. All right, so the integral of dy dx is y, and how do I know that? Well, what's the derivative of y? dy dx equals, all right, when I integrate this bad boy, I'm going to get 3x cubed divided by 3 minus x plus c. And I'll clean it up and say y equals x cubed minus x plus c. All right, I want you to box that in. I want to be very clear. Let's put a GS there. That is our general solution. We're going to go one step further and get our particular solution by substituting in the point 2, 4. So I'm going to say 4 equals 2 cubed minus 2 plus c. 8 minus 2 is 6. 4 equals 6 plus c. C equals negative 2. Lastly, I'll write my particular solution. And I'm going to say y equals x cubed, oops, my pen is really dying, minus x minus 2. And this is the particular solution that satisfies that initial condition. All right, you've got this one on your own. Find the particular solution, dy dx equals 1/2 x squared minus 2x at the point 6, 2. So remember, get your general, then use your point, your initial condition, should say, to get your particular solution. Pause it, and then play back and see if it's equivalent to mine. All right, hopefully that was a piece of cake for you. If not, again, just slow down and try it again after you go through it. Practice it again. I've simply integrated both sides. All right, wrapped each side up with an integral. The integral of dy dx is y. If you're not sure, the derivative of y is dy dx. I integrated both sides, and I've got my c value. Here's my general solution, 1/6 x cubed minus x squared plus c. I substituted in my 2 and my 6, and I ended up with a c equals 2. I had my 36's cancel, and here's my particular solution to this differential equation. All right, we've got a big bear for you here. It says solve the differential equation. Now take notice, they start with f double prime of x equals x to the negative 4/5, f prime of 1 equals 8, and f of 0 equals 3. So I basically have two initial conditions to get me to f. All right, so let's start by wrapping each side up, of course, in that integral. And just slowly talking our way through it. Remember, slap a dx on that bad boy. All right, if you integrate f double prime of x, who do you get? Hopefully you're saying just f prime of x, because the derivative of f prime is f double prime. Equals, now let's go ahead and integrate this. Remember, we're adding one, unlike deriving where you subtract one, we're going to add one here. So I'm going to say this is x to the, picture adding 5/5, that's x to the 1/5, and instead of dividing by 1/5, we really just say times 5 plus c. All right, now I'll use my first initial condition. I need the one that has the f prime in it. Okay, when I substitute 1 into f prime, I get 8. So 8 equals 5 times 1 to the 1/5 plus c. 1 to any power is 1, and 1 times 5 is 5. Subtract my 5 over, and I get c equals 3. So now I will write out my new f prime function. F prime of x is equal to 5x to the 1/5 plus 3. So that was my general solution. I now have a particular solution. All right, now they want me to get to f, so I'm going to integrate both sides again. So I'm going to wrap each side up. Okay, I'm going to integrate each side. Don't forget your dx. And now let's actually integrate. Who do you take the derivative of to get f prime of x? Well, that would just be f of x. All right, again, I'm adding 1, so I'm picturing that 5 5s, but I'm adding it. So I'm going to say x to the 6/5, and instead of saying divided by 6/5, I'm actually saying times 5/6, plus, if I integrate 3, that's 3x plus c. I'm going to clean that up a little, so I get f of x equals, let's see, that's 25 over 6, multiply tops and bottoms, x to the 6/5 plus 3x plus c. Lastly, I'll go grab that initial condition for the f of x family, and when I'm just plain old f of x, I'm using 0, 3 as my point. So I'm going to say 3 equals, let's see, if I plug a 0 in here, 0 to any power times anything is 0, plus 3 times 0 is 0, plus c, so basically c equals 3. And my function then itself is f of x equals 25 6 x to the 6/5 plus 3x plus 3. And that is the particular solution that satisfies all those given conditions that we started with. Okay, so notice I had to go pretty nice and slow, taking one at a time, starting with f double prime, getting f prime, and then working my way to f. Well, believe it or not, I think that does it for us tonight. Take your time integrating each of these separately and really practice rewriting them. I think that will make your integration much smoother. Have a great night, and we'll see you tomorrow.